Alright guys, we're going to do solving systems of equations with two variables. And what that means is I have like two different equations. Something like this. And I want to see where the two lines meet. So one of my lines is going to look like this. And the other line is going to look like this. And so what we're looking for is this point where the two lines meet. That's what we're always trying to find. Now we know that there's always a couple of special cases. The special cases on this would be if the lines were parallel, there would be no solution. So we would put an empty set there. All right. If the lines were right on top of each other, it would be all real numbers. So we will go like that. So those are the two special cases, and I'll show you how to tell if that happens on the ones when we actually do them. Okay, so this is what we're looking at today. We're gonna look at solving using elimination. So I usually use elimination when they're both in standard form, and standard form looks like this. So that's where x and y are on the same side and the numbers on the other side. The reason that I use that is I can just subtract this bottom row from the top row and the x's are going to cancel out. 2x minus 2x is nothing, so those are gone. 3y minus 6y is negative 3y. And 14 minus 11 is 3. So then I divide by negative 3 to get the y by itself. Gives me y equals negative 1. I'm not done yet. I have to take this and put it back into one of the equations. So 2x plus 3 times negative 1 equals 14. 2x minus 3 equals 14. I'm going to add the 3. 2x equals 17. Divide by 2. X equals, I'm just going to leave it as a fraction, 17 over 2. So remember I told you what we're looking for is we're looking for this point where they meet, which means I need to write my answer as a point. On a point, the x always comes first and the y always comes second. So this is the point where those two lines will meet. A few more examples. So I have these two right here. Again, I'm going to subtract so that these x's cancel out. So 3x minus 3x is gone. Negative 6y minus 2y is actually negative 8y. And 14 minus 12 is 2. Then I divide. This can be simplified to negative 1/4. Remember, I take what I get and I plug it back in for y. So 3x minus 6 times negative 1/4 equals 14. 3x plus 3 over 2 equals 14. I just multiplied these together, give me 6 over 4, which reduces to 3 over 2. I'm going to subtract the 3 over 2. But this makes me sad. So I'm going to put it in the calculator. 14 minus 3 over 2 gives me 25 over 2. And then I'm going to divide by 3. And that's going to give me 25 over 6. Remember, we're trying to write it as a point. So we're going to put 25 over 6, negative 1/4. Now there will be some that are a little bit tougher. I'm going to write on this, but I'll use a darker marker so it makes it easier to see. I'm sorry, I don't have any blank paper in front of me. So sometimes we'll have stuff like this. So on all the other ones, my x's were the same number, and on these ones, they're not. So what I do is I multiply everything in the top row by the starting x value, which is 3. Everything in the bottom row by the starting x value, which is 2. So this is going to become, this first row right here is going to become 6x plus 9y equals 42. This bottom row is going to become 6x plus 24y equals 84. Now I can subtract the bottom row from the top row. 6x minus 6x is nothing. 9y minus 24y is negative 15y. 42 minus 84 is negative 42. Divide by negative 15. Negative divided by a negative gives me a positive. That's going to reduce to 14 over 5. I'm going to take that value and plug it back in for y. That's going to give me if I want to make it so I'm not dealing with fractions, I can just multiply this whole thing by whatever number's on the denominator. So that's going to give me 10x plus 42 equals 70. Subtract the 42. Divide by 10. And that's going to reduce to 14 over 5. Remember, we're always trying to find the point, so I'm going to put 14 over 5, comma 14 over 5. They're the same number? That's hilarious. 14 over 5. So that's how we would do those. We'll do a couple more examples in class.